This time of year makes me think of the old days. Luke Skywalker is a Jedi. Jedis are the peacekeepers of their galaxy. Luke Skywalker grew up on the planet Tatooine. It once had many oceans and rainforests, but for unknown reasons, it became a desert planet with very little water. Because of the lack of water, moisture farmers on the planet use moisture vaporators to capture water from the planet's air. This is a moisture vaporator. Thinking about our own planet, you might be able to think of places like Tatooine. You probably already know that 70% of our planet is covered with water, but only 3% of that water is fresh water, which is what we drink and bathe in and water our crops with. But there are some places that are much more like Tatooine than you might think. Areas such as Sudan, Venezuela, Ethiopia, and Cuba face water scarcity. There are different reasons for water scarcity, whether it is an actual lack of water or the inability to move water to where it needs to be. But don't think water scarcity is just a problem for other parts of the world. Water scarcity affects parts of our own country as well. There are places right here in the United States that struggle with having enough water for its citizens. Las Vegas is outgrowing its supply of water. The area gets 70 to 90% of its water from the Colorado River. It gets the rest from groundwater and pipelines that pipes water from other parts of the country. But that won't be enough for much longer. Officials wanted to pipe even more water from eastern Nevada and Utah. The only problem is the people in those areas had a problem with it. Farmers, residents, and water sports enthusiasts are just a few of the groups of people who argued that if Las Vegas piped water from areas such as eastern Nevada and parts of Utah, it would hurt those areas far more than it would help Las Vegas. And after 21 years of battling in court, finally, in April of 2020, Las Vegas gave up the fight. Don't worry too much about the residents of Las Vegas. Las Vegas was going to spend billions of dollars building that pipeline. For billions of dollars, very smart people can come up with a whole lot of ideas. One of the most popular ideas is a desalination station in Southern California. I must say, I am happy that Las Vegas will survive, because so will my summertime job. Desalination is the process of separating salt from seawater, and some experts believe it could be the solution to solving water scarcity around the world. But what about those areas that are like Tatooine? No oceans around to desalinate. What about places like here, right in the middle of Africa? Remember those moisture vaporators on Tatooine? They aren't just in the movies. Well, these are, but a version of those exists here on Earth. People have been extracting water from fog for a while. Typically, a mesh is placed in the air, and as the fog or cloud passes through the mesh, the moisture or water gets trapped. in the tiny holes. But, of course, it's not quite a simple thing to catch water droplets in a mesh. Water droplets are only 10 microns in diameter. That is the distance from one edge of the water droplet to the other through the center. That's very, very small. See that giant-looking brown tube? That's a human hair. See that tiny, tiny white dot? That is 1 micron. 10 microns wouldn't even fill up this red circle. Most of the water droplets go right through the mesh. Typically, only 2% of the moisture that passes through is trapped by the mesh. If the mesh is successful at collecting those tiny droplets, the openings of the mesh will eventually become clogged. So, researchers coat the mesh with a special substance that makes the water droplets fall off quickly. But then we're back to the size of the mesh again. It seems clear that smaller holes in the mesh is the answer, but actually, the smaller mesh is harder to make and is very strong. The answer to this is a scientific one. Scientists insert ions into the fog, giving it a positive or negative charge. Let's say, for this case, the scientists gave the fog a negative charge. What are negative charged ions attracted to? That's right, positive charged ions. So, the scientists charge the mesh with positive ions. The water droplets are attracted to the mesh and stick to it. Then, because of the special coating, they fall right into the collection container. It's not an easy way to collect water, but it works. We are going to make our very own moisture vaporator or water harvester. You can use a variety of materials. It would actually be great to experiment and see what material works better than others. Here's what you're going to need for the activity. 2 popsicle stick frames, glue, 2 jars with sand, rubber bands, 2 pieces of paper towel with slits cut in the middle, mesh, I'm going to use tulle and knee-high hose, a kitchen scale, it really needs to measure down to 1/100 of an ounce, and a water bottle that spritzes. So you can see I have taken the jar with sand, the paper towel with a slit, rubber band to the top, done that with both of them. I took the knee-high hose and trimmed it. I placed it over the frame, trimmed off the edges just a bit at the bottom. I'm left with this that you can see through. It is a mesh. This is the tulle. Cut pieces off of the spool. 2 pieces, 1 glued to each side of this frame. Just place it into the sand through that slit in the paper towel, just like so. And with our kitchen scale, we are going to weigh each one. 14.7 ounces. 13.7 ounces. I'm going to get 1 extra paper towel for the next step. With our spray bottle, we are going to spray a mist of water right through, simulating a fog, a cloud. I'm going to do 10 spritzes. 1, 2. You can see the paper towel moving on the other side. It was definitely getting through. Quite a bit of it went through on the paper towel. try that again with the knee-high hose filter. 1, 2. The paper towel didn't move, barely. It is not wet. This is wet, very wet. So, caught so much of it that the paper towel is now falling apart. Let's weigh it. 14.9. 13.8. So this one definitely did catch a little bit more water, but most of it is still on the mesh. You can see right here. And so this is why scientists coat the mesh with a special substance. It makes the water just fall right off, and it would fall into the collection container. And it did a bit on this one. You can see the paper towel is very wet. It fell apart because it got so wet. This smaller mesh, it is a mesh. You can see through it, but it's much smaller than this one. So you can see. Now, I would love to know if you try something else besides hose or tool. You may have other materials lying around that might work better. I would love to hear it. So, if you do the activity, send me a message in Google Classroom, send me an email, let me know how it goes. Until next week, my friends, may the 4th be with you. Puff, quit chasing the cat with your lightsaber. Its hair is still growing back from the last time.